Okay, I know it's Thanksgiving break week and that you technically only have 2 days of school, but we do have some lessons to get through today, 5.5 and 5.6. So we have 4 goals. To be able to identify angle relationships using side lengths of a triangle, to be able to identify side length relationships using the angle measures of a triangle, to be able to determine if 3 sides can create a triangle, and to find the third possible side of a triangle when given 2 side lengths. All right, so let's use angles to determine side lengths. So here's the rule. Short is always across from small, and long is always going to be across from large. Okay? So that's the rule. Short and small are across from each other, long and large are across from each other. So, for example, if we want to order these sides from shortest to longest, okay? Shortest to longest. So we're talking about our sides. So the first thing you need to do is find your smallest angle. So our smallest angle is 50. Okay? That means across from 50 is your shortest side. So our shortest side is side CB. Okay? To find the longest side, we need to look for the largest angle. So our largest angle is 70. Well, across from 70 is CA. This would be our longest side. So who does that leave for the middle? AB. And ta-da, you just listed them from shortest to longest. There we go. All right, let's keep going. What about if I wanted to name my sides from longest to shortest? So we're going to start with our largest angle. So our largest angle is 76. Well, across from 76, this would be our longest side, YZ. All right, and our shortest side is going to be across from our smallest angle. Our smallest angle is 31. Sorry, 31. And across from it is our short side, XY. So that leaves for the middle, XZ. Ta-da! And remember, order doesn't matter on these names. So you could call this ZY as well, or this ZX, or this YX, okay? So these are going to be multiple choice, so remember that the names can be interchangeable. All right, now using sides to determine angle measures. Guess what? Your smallest angle is going to be across from your shortest side. And your largest angle is going to be across from your longest side. Oh my goodness! Who would have ever thunk it? So let's go ahead and order these angles from smallest to largest. So this means we're looking for our shortest side. So the shortest side is 14. So the angle across from 14 is angle B. So this is our small angle. Small. All right, now for our largest angle, we need to look for our longest side. So our longest side is 19. So across from 19 is angle C. This is our large angle. So what angle does that leave for the middle? Angle B. Ta-da! We just listed them from smallest to largest. All right, what if we wanted to go the other way? Largest to smallest. Same rules apply. So we're going to be looking for our long side first. So the longest side here is 20. Across from 20 is our large angle, angle S. Okay, now for our shortest, our smallest, we're going to look for our short side. Our short side is 15. And across from 15 with our smallest angle, angle T. Who does that leave for the middle? Angle U. Ta-da! There we go. We've already finished the first 2 goals for today. Being able to use sides and angles to manipulate length. Alright, now, super duper fun, triangle inequality. Now, what triangle inequality theorem is telling us is that for a triangle to exist, we'll always follow the following rule. Okay, you take the 2 smallest, shortest sides. Add them, and they need to be greater than the longest side. Alright, so this is very important here. This is what we are fixing to do to determine if a triangle exists. So what I like to do is I like to take my 3 sides I'm given. For example, 5A, we're given 9, 6, and 10. I put S's with my small numbers and an L with my longest. So my longest is 10, and these are my 2 short ones. So what needs to happen here is we need to take 9 plus 6 needs to be greater than 10. Well, what is 9 plus 6? 15, I do believe. Let me check my math. I've been doing this all day and I'm kind of tired. Okay, here we go. Yep. Is 15 greater than 10? Yes, it is. So yes, that is a triangle. Let's look at example 5B. All right, so my longest side is 17, leaving these 2 to be my short ones. So I'm going to say thought I picked one that was a no, but I didn't. Oh well. Alright, so 10 plus 8 needs to be greater than 17. What's 10 plus 8? Why, it's 18. Is 18 greater than 17? Yes. Alright. So, if it's not greater than, your answer is no. Alright? Okay, now, finding possible side lengths when given 2 other sides. There is a formula for this, and your answer will be written as an inequality. So x represents our third side. Okay? And we're creating a range, because a whole bunch of different numbers could fit into a triangle when given 2 sides. So we're going to know that x has to be greater than a certain number, but less than another number. So how we find this side here, to find this small possible, this is small. For the small side, we're going to subtract. So small, subtract. Guess what we're going to do whenever we want to find the large side? We're going to add. So let's look at example 6 here. We want to know what is the possible range for our third side when a side length of 6 and 7 are involved. So our range, so to find this side, we're going to say, okay, 7 minus 6 is 1. To find this side, we say 7 plus 6 is 13. Ta-da! That is your range. All right. Do not forget about your Google form. Also, do not forget about taking a picture of your notes and turning these in. Have a wonderful Thanksgiving.